That's all. Make sure you spell, make sure this, make sure you spell fibrocartilage like that.
Yeah,
You know, and fibro.
There are 5 cases on the.
Yeah, but I did on my.
because you don't get 100%, you get right on the 5th answer. 63% or 54%.
Yeah.
Well, I'm trying to answer it, but no one can answer it.
I looked today, and it's only got 25 people registered in the My Labs, which means there's over 20 people that didn't get registered. So if you didn't get registered, is it because you are having trouble getting registered, or because if half the class is going to do it, then we're just not going to do it?
Straight up forgot.
What? Forgot?
Yep.
Okay.
Did you get those access codes?
No, and so what you'll have to do, here's where you may have, it's first getting weird. The others, according to the rep, the other schools in the world are on semesters, and they're not all on semesters. But somehow, because we're on quarters, what's going on with semester schools, and the person who's in charge of all that is doing some things with the semester schools, they can't get to us right away. If you have the orange book, you're supposed to be able to get in though and get a temporary code. So when you go through the process, where I was showing you that last week, you get to the point where it says temporary code, and you should be able to get a temporary code, which will do exactly the same thing. And so that'll kind of take care of that issue. The problem I'm having is with the people who don't have the orange book. That means you don't have any way to get in at all. So how many people are there that are in that position?
I don't have the orange one, and I was able to get in.
Me too.
Oh, were you?
And my temporary code says it's good till June
Yeah,
2013.
Mine does
Now
too.
temporary.
Yeah.
Okay.
You have to go online to where it shows, and then you click on the buy. See, I clicked on buy now, and then I back clicked, and then I saw a thing that said access temporary code now. Yeah.
Yeah.
And then it gives you the code, and then you have to go back and just type it in. And
Yeah, you can't cut and paste, you gotta type it.
Right, and then it said that it was good until, like, mine's June 29th. Even though it told me I only had 21 days, but then it says it expires June 29th.
But with your book, you should have been able to get a code.
No, I didn't buy my book now.
Oh, okay, so you didn't buy it.
And my book's really old, my stuff did too.
Well, what I'm gonna do is, this is the one for this week, so I'll go ahead and hand it out to everybody. And if you can get on and do it by the computers, that's fine. So, I want you to get everybody on in about a week or so, we're gonna sit down and talk about, I have, some concerns about, people have to get on a computer and then you have access to the computer. So we'll kind of talk about how this works for you. And then if it's kind of a hassle, we're just gonna kind of stop. You still want to have the temporary code though, because this will give you access to the publisher's website. The publisher's website, the PhysioAct and the Interactive Physiology CDs, both that came with the books, are actually on their website. Plus, there's quizzes and practice things that you can do that sometimes students find helpful to study. So you still want to try to get access just because you have some extra things that the publisher has there that might help you out.
I don't know if anybody, there's a few people over here experiencing this, but when I was taking my test, it would freeze up and throw me on some online dating site or like, I did submit, and the answer I put was not fair, so I did not get the grade I wanted. But it kept throwing me off these weird sites that it was weird. So I don't know if you've heard anybody tell you that yet.
I haven't heard that yet. I know who's, Manley, who's, there you go, I need to go back to you emailed me today and it was all locked up today.
Yeah, actually that was last night. I got it fixed somehow. I'm not sure what I did to it, but
Okay.
it's working again today.
That was the concern we had last term, we hadn't heard, because sometimes the site just fell apart.
Same here.
When I hit submit, it would go away and I'd be on some weird site. And it was just like.
I was having issues.
You were having issues?
Yeah, it was weird, it was driving me crazy.
Okay, so that's the kind of stuff that's, I'm sorry you guys are sort of our guinea pigs, but that kind of keeps it happening. And so here's what, so if you're worried about some answers didn't get through, okay, so did it let you go back and redo it? So how many do you think you lost?
I got a 71, so there was 2 that I couldn't answer the type-in ones,
Uh-huh.
and then there were 2 that, the one that I clicked, it went.
You wouldn't go through?
It wouldn't submit. I haven't any too.
That's one point if it's 4 questions, so, one of the things we're not gonna do is hold you guys kind of, we're gonna hold you harmless, we're not gonna read this kind of issue, so, that's equal to 4 questions. So I have a system where I give points back, and then we'll do our first test, so we'll show how it works, but what I'll do is I'll record, and so, when I do give backs for bad things, it's for everybody, so if you got a break rate on this, good for you, you're gonna get an extra point, but I'll just give everybody in the class 1 point on that, so that'll, anything that's not on, that'll probably take care of it. Does that make sense? Yeah, we'll keep kind of working on this, and my feeling is that this is the same stuff that happened last term when we had to give up and we had to fix it. So we may just give up and go to the deeper ones, and that's fine. I can do what I need to do, and create data I need for college. So, and that's what this is all for anyway. So we can do it in a way that's probably easier for you guys. So that's okay.
So we got stuck on that side road part of the answer, and we're gonna end up giving that back.
Yes, I was gonna give everybody a quarter point back for that one, but it sounds like there's some other kinds of things going on, so let's give everybody a point back, so that's 20% of the whole score, so that should take care of it.
What are you doing? Frontal, distal. I have neither at the moment. You too.
My name. Andrea Emilian. I'll upload the videos tonight. I haven't done it yet. It's not gonna Andrea Emilian.
Gotcha. I just typed it in and it doesn't come
I
up.
should pull it straight up.
Yeah.
There was a dog video.
I didn't find it the first time I brought the end, but yeah, if you go to YouTube, space on Andrea and I'm like, do you still have all your biology ones from last term?
Uh-huh.
They all in the same thing?
Yeah.
And then you said listed by like, that's right, extra one or.
I haven't put these ones up yet, but I will. Last time I had them by like chapter, I think.
Yeah.
I had them by chapters.
Oh.
I think I was gonna go back and look at just the self-respiration.
Yeah.
Because we're gonna be talking a lot about it, so I think I wanted to touch on this next time.
It's kind of neat where like in the epithelial cells, you know, how the mitosis is happening.
Yeah, yeah. So it's like I wanna.
I know what that is.
I know my.
Yeah.
Yeah, but
I think it was a metaphase. I was like, oh yeah, I know that.
I know what that looks like. I can draw that.
I could totally draw that.
I'm totally trying to block it out.
Worst for me was the app where, you know, when you're doing the chemical, chemistry aspect.
Really?
Well, the equation.
See, I had a really good high school teacher that like drilled it into our heads how to do that. That was great.
That's the whole piece.
Wow, that was a long time.
So do you have to?
If there's anybody else that did not, get that email that had the honesty contracting on it,
I
I
did, and I
tried.
cannot print it out, so.
Right, I had some tonight, you can come up tonight and give them back to me on Thursday. All right, so let's keep going. Honestly. Good.
So this week, we send it to next week.
Yeah, so everybody says, like, this will be due next Tuesday.
21st.
Is that the 21st?
That's what the computer said.
The next Tuesday is Wednesday. All right, so, is it, whatever day it is, Tuesday.
Yeah.
You guys can wait to me. Gotta relax a little bit, this class.
Worried about you, not you.
Do what?
I'm worried about you, it's a terrible thing.
Well, if it's Tuesday, it's Tuesday. But the first day of next week, whatever day it is, it's Tuesday, right? So this is where we left off last time. Really quick review. If it's a plane that cuts you into anterior and posterior, it's frontal, what's our other word? Frontal. If it does you superior and inferior, or horizontal, very good. And if it cuts you into equal halves, left and right, and if it's off the midline, parasagittal, good. And so a horizontal plane, somebody said, would cut you in a cross section, right? So a sagittal or frontal plane would cut you in a longitudinal section, all right? And then if we took a look at any kind of cut that was not at 90 degrees to these guys, it would be an oblique. And so it's going to cut you at some kind of oblique angle, and it's going to be quite variable in terms of what that would actually be. So if we take a look then at how we would use this in what it's good for, you can see, on these illustrations that they have, this is what we would look like with the frontal plane. So this is going to be a longitudinal section with a frontal plane. This is a longitudinal section with a sagittal plane. And this is going to be a cross section using that transverse plane. So when we take a look at this guy then, the plane it's cutting in is transverse, and so this is a cross section. And so when we take a look at the picture that we see up here, is this a superior or inferior view?
No, inferior.
Okay, you did hear that already last week, correct? What side of the rat's body was the liver on? The right? The upper portion of the abdominal cavity, correct? And so here's your liver, where we have to look at this in terms of anatomical position, correct? So it's on the guy's right side, so you talk about your patient, look at the way he's laying. So is your view an inferior view or a superior view?
Inferior.
This is an inferior view. So when you take a look at any section and you create two parts, you have two sides or two ends to look at, and you have to figure out whether you have an inferior, superior, lateral, whatever it might be, or median view.
Could you explain, superior view of life? Like, how would you have any?
Sure, if I cut this guy in half, right? That's all I'm going to take. We're actually not, we're creating an image is what we'd be doing, but let's say we're going to pull this guy like this, right? If I'm looking up into him, I'm looking from an inferior position. If I'm looking down, I'm from a superior position. So this becomes a superior view, this is an inferior view. If I'm looking at it from in this direction, it's well, what are our directional movements here? So I'm more lateral away from the midline, right? So looking at him this way, so we're going to just do a cut. Look at this person's body and size here. This is a lateral view. If I was looking this way, it would be a median view. All right, so let's go. So take a look. Here's an X-ray. And so in this case, it's a lateral view. Right? We're looking at this guy from the side. And this just happens to be a scan of exactly the same anatomical structure. And with a scan, depending on what we're doing, we just get a different kind of view. Once again, this is going to be a lateral view. Are we okay? Does that make sense? Okay, so as we go along, you started tissues today, so tissues right now we're only worried about mostly cross-sectional, longitudinal section in terms of how they were cut to give you an idea of how they were taken out of the body. But as we go along, we'll constantly talk about what kind of view is this, what kind of view is this, what kind of view is this. So when we take a look at how you're organized, you have these really large cavities, and then we fill these cavities up with different kinds of organs and tissues and things like that. So when we take a look at Martini's new book, every time they write a new edition, they need to make some changes. And so what Martini did in this new textbook, so if you have one of the old textbooks, you're better off, he left out the dorsal body cavity. He's decided that that's not a cavity. In your lab book, Marion left the dorsal body cavity in. So that's really the one you want to pay attention to. Is we're going to say we have two major body cavities. And those two major body cavities are the ventral body cavity and the dorsal body cavity. Does that make sense? All right. Now, how many do you have? Two. What are they? Dorsal and ventral. Do you have that?
Yes.
That has a tendency to show up on tests, and you have a tendency as students to get it wrong. And so you have two major body cavities. What are they?
Ventral and dorsal.
Dorsal and ventral. Good. Now, the dorsal body cavities, the easiest one to deal with, because we divide it into two subdivisions. So our two subdivisions are the cranial cavity and the spinal cavity. So the cranial cavity is what's up here, and that's the big space that your brain is occupying. And then the brain is connected to a long neural tube, our spinal cord, and it occupies a space that goes down our vertebral column inside of it. And so that's going to be called the spinal cavity because it contains the spinal cord. So our dorsal cavity is made up of the cranial cavity and the spinal cavity. Okay?
It also is called the vertebral cavity.
Yes, Mary calls it the vertebral cavity, and that's okay. And I think I told you guys, if you find a word and I mark it wrong, or one of the, or Jim marks it wrong, I guess she's going on to lab this term, and it's actually a good word, just point it out, if it's a good word, and we'll give it back to you. So either one of those are okay. Good question. So vertebral cavity then is going to be in the front, because the dorsal's in the back. And we divide that into two big sections, the thoracic cavity and the abdominal pelvic. So when you cut open your rat, did Jen have you stop at the sternum and then slice this way and stick your finger up there and rub up and feel the diaphragm?
No.
No?
Look for it.
Oh.
Just a pretty much you end up butchering through it.
No, not if you just cut up to here and go over and the wrist and it stays right here and you can feel it. Bummer. Okay, so if you had done it that way, what you found is you could not get your finger up into the little rat's chest because the whole, all the way across, this diaphragm was all the way across, so the whole abdominal pelvic cavity is kind of separated by this big gigantic muscle. And it's what forms a big dome, which is really what I want you to feel, because when we get to 233, we'll talk about that diaphragm flattening out. And if you can see it, the dome, then you understand what it contracts. It's going to go like this, and it makes breathing a little easier to understand.
Does it belong to either thoracic or abdominal
It is
cavity?
basically the separation between the two.
So it doesn't belong in either?
Yeah, I never even ask which one does it belong to because it's our anatomical boundary between the two. And so it's on the board for both, you could say. It's
That's
important way to
what
look
we
at it.
thought, yes.
And so in our thoracic cavity, we have a bunch of different guys, and then in our abdominal pelvic cavity, we just have two. So we're just going to do these two. So the abdominal pelvic cavity then is from the diaphragm down, all the way down to here. And it's divided into the abdominal cavity, which is up here. And then we have the pelvic cavity, which is down here. And when we get to these guys, we'll look at it in a little more detail in just a minute. There's really no super cool physical boundary that separates the two, so we sort of make it up in terms of anatomical landmarks to say this is where one starts and the other one ends. In the thoracic cavity, you have a cavity that houses each of your lungs, which is called the pleural cavity. So now, if you have pairs of things, pairs of organs, pairs of bones, pairs of muscles, then we always have to designate right and left. And so if we're doing right and left, I know the picture's coming up in just a little bit. If we're doing right and left, Roy's talking about anatomical position, correct? All right, so that is your patients, specimens, victims, whatever it is that you're doing. It is their right and left. Nobody cares about your right and left. And because we're always going to be dealing with our patient through our specimen, we can all differentiate the correct right and left. All right? Except for those handful of times every year where they cut somebody's leg off and they cut the wrong one off. So they remove a bad kidney and they get it wrong and they remove the healthy kidney instead. And that happens every single year. And so if we remember anatomical position and we understand what we're doing, then we don't make those mistakes, which is why when you go in now, 5 different times you have to agree that, yeah, this is what we're working on, this is what we're taking out. And you hope the doctor still remembers, you know, when
They write on the Sharpie.
what?
They write on the Sharpie.
I would assume when they cut these bad guys out in the first place, they would have noticed that anyway. So,
Yeah.
when I went in for my leg surgery, we wrote initials on my leg, and the nurse and I, and the doctor wasn't in the room, so I took the Sharpie and I put wrong leg. And he, being a real crack up, had this tendon that's just super sore. And he walks out and looks at all that, and he reaches down and grabs that sore spot, squeezes it, and my leg jumps. He goes, "Is that the correct leg?" And I'm like, "That's the correct leg." I won't forget. Neither will I. So anyway, so you have left and right here, correct? We have to designate. And then we have our heart in the cavities. This is called the pericardial cavity. And then we have some stuff that's kind of left over. Now, depending on who you are as an anatomist, some anatomists will say you have the mediastinum as a cavity, and within that cavity, we have the pericardial cavity. What I like to do is say we have these 2 cavities, we have this cavity, and if it's not these 3 cavities, it's the mediastinum. Everything that's left over is mediastinum. Are we okay? All right. So this is Martini's subdivision. This is so familiar. It's in your textbook. But what did he forget? The dorsal cavity. The dorsal cavity contains the cranion. Which one has the spinal cord? Which one has the brain? So good job. Alright, so taking a look then at these cavities and sort of how they're made up. Your goal today was to get through epithelial tissue for your tissues in lab, correct? And maybe start on connective. And then on Thursday, your goal is to review epithelium and do connective. And then your goal for next week will be to review epithelium and connective and finish the muscle and nervous tissue. Did Jenny go over that with you?
Yeah.
Okay, that's kind of your plan for the next 3 labs then. Okay, so when you take a look at these cavities, then you learn today that epithelial tissue has a tendency to line and cover things. So when we take a look at these cavities, they're all lined with epithelial tissue. And in essence, it sort of helps create these cavities. So when we're taking a look at like your heart or the throat cavities where your lungs are, what you have to think of is I'm starting out with this big, nice open cavity, and there's a membrane that goes along here. And then what will happen is we're going to shove along into here, and shove along into here, and shove the heart down into here. And then these organs actually occupy most of the space. They take up that space, and there's going to be a little bit left over. And that's what they're trying to show you right here. Here's the heart. Here's this double membrane. And what happens is it's surrounding the entire heart, but the heart pushes this membrane down. And this is all you have left of the cavity of the space that's there. And so, nice illustration, if you had a balloon, and the balloon is kind of soft, and you stuck your hand down in the balloon, well, what happens is the balloon will surround and suck under your hand, and so the balloon used to have a big, gigantic space, but when you stuck your hand down in it, now the space just surrounds your hand. It's the same amount of space, but a different configuration. Does that make sense? Okay, so in our thoracic cavity, we have these different cavities that are here, so 2 pleural and pericardial created by filling up this space sort of with this organ. And so the space ends up being, instead of this, it's just this. All right, does that make sense? All right, that's truly your cavity at this point. So there's our heart in the pleural cavity, there's our lung, and then all of this is mediastinum. So do you see why they say the heart is located in the mediastinum? Because if you think of this as being a big space, then the heart actually occupying that space. It's just as easy to say, okay, this is a cavity, and this is a cavity also. So if it's not heart, it's not here, then it's got to be mediastinum. So it's just a different way to say exactly the same thing. Have I lost you? Okay. And so, here's our diaphragm, double white muscle is here. And this is our abdominal pelvic cavity. And so what you have is a double membrane that fills up most of this structure. Down here, what will happen is the membrane will stop, and there are bladders sitting right here, and some of our reproductive organs are in here. So those guys are actually outside of this membrane that's here. Anything that's not inside of the sac is said to be retroperitoneal. And as we go along, we'll talk about different organs that are actually truly in the cavity and truly kind of out of the cavity because they're not within that sac. Questions?
Can you turn off the lights?
Yeah, I can. It just makes me feel like I'm in a cave. But you can certainly see better, can't you? No questions? Okay. And so, once again, just that same idea of how we create these cavities. And then, when we take a look at the abdominal pelvic cavity, because we are talking about these guys always having two, let's go back to this side. So, when you take a look at these cavities and their double membranes that they have, there's a naming system that we use. And we'll talk about this again when we talk about epithelial tissue here in just a little while. So if I have a double membrane, so I've got a membrane that's here, so everybody see there's a space, there's a membrane here, right? Okay. As a membrane here, there's a space, there's a membrane that's present here. So the membrane that touches the organ is called the visceral membrane, all right? And the one that doesn't touch the organ is called the parietal membrane. So this membrane is called the pleural membrane. So this is the parietal pleura, and this is the visceral pleura. So that's the one not touching the heart. The heart's got a pericardial membrane. That's the parietal pericardium, and this is the visceral pericardium. So this is the abdominal pelvic cavity. And this cavity is called the this isn't in your book in this chapter. So this is called the peritoneum. Once again, it'll be a double membrane. So let's take a look. Here's the membrane that's touching the body wall. Right? So this is our abdominal pelvic cavity. Line is the abdominal pelvic cavity. And this would be the parietal peritoneum. As it covers the liver, right? So it comes up and then continues on and covers the liver. Now it's called the visceral peritoneum. Do you see how it's going to work? So viscera means guts. Guts are organs. So the visceral membrane, visceral pleura, visceral pericardium, visceral peritoneum is always going to be the membrane where it's touching the organ. And then remember, this is a continuous membrane. Let's go back. This would be visceral. This would be parietal. This is parietal. Are we okay?
Yes.
The same, it's consistent, and then we just call it visceral parietal, and then we say which membrane we're talking about. Are we all right? Now when I get into the trick here, I'll make sure we're good. The good news and the bad news. The good news is you don't have to know all of the next part I'm going to tell you right now until we get later on. The bad news is that you're going to have to know it later on. So what happens here is that when we look inside the abdominal pelvic cavity, there's kind of some interesting things that happen. The other kind of cavities that we were talking about inside the thoracic cavity, the cranial cavity, the spinal cavity, it's like you just got this one organ that's there. So it's pretty simple. The outside, membrane comes around and it attaches to the organ that surrounds the organ. It's a simple kind of structure. But when we take a look here, now all the way up here, this is getting some peritoneum all along the front of your abdominal pelvic cavity. Then it comes up here, and then it attaches to your liver, and it goes like this. On the back side, it's doing the same thing. It comes up and attaches to your liver. It's covering your whole liver. It's like I think 363D. And then it comes down here, and now it goes from here, and it's going to go down, and then attach to your stomach. So when these membranes meet, then it's a double membrane, and then it goes around your stomach. Double membrane coming down all the way up, goes around your transverse colon, that's the upper portion of your large intestine, goes back over in the wall, comes around all the small intestines, and so we end up having some special kinds of membranes that are here. So these guys are collectively just called the mesentery, which you've probably heard that term before. And so they're still part of the kind of the peritoneum, but we talk about them differently to designate that they're not the organ guys, and they're not the cavity guys. They're the guys that are kind of in the middle, connecting everything and holding everything in place. So when you picked up your rat's intestine, I'm assuming you did that, and you tried to pull them out, right? Did they all come out in one big chunk kind of thing? And they were all kind of connected together, and you saw this kind of opaque membrane that was connecting everything. That was the mesentery. Right? Does that make sense? And the mesentery is an extension of or part of our peritoneum. And so what happens when we get to the digestive system, they kind of want to talk about these and have special names for them to designate where they're at and kind of what they do. So all this mass in here is called the mesentery proper. And some of the other ones have different names, but they tell us what goes on. So this is called the transverse mesocolon. Transverse is because this guy's going this way across your abdominal pelvic cavity, and mesocolon tells us that it's connected to the colon, and it's connected to the middle portion of the colon, which is what the transverse portion is. Are we okay? And so the names kind of tell you stuff, and we don't have to know all of these yet. But do you have the configuration? Okay, now when you look at these membranes, you notice that they have blood vessels and other little sticky things going through them. So these guys are really packed with blood vessels and lymphatic vessels. And so as you digest food, all of the material that you digest actually goes into the blood vessels that make up the mesentery, and eventually they're going to make their way to the liver before they go anywhere else. So if you get a ruptured appendix, and the appendix is connected to the large colon right by where the small intestine is, and if that appendix ruptures, it's full of bacteria and stuff. And then it gets out in here and affects this mesentery. And if they spread in the mesentery, it gets into those blood vessels, it takes off and goes all over. Pretty soon you have systemic infection. So anybody who gets a ruptured appendix almost always ends up being on IV antibiotics because they're so worried about this massive infection that can occur. That make sense? So appendicitis with it's just appendicitis. Appendicitis is alright, so it's, oops. Where's my quiz? Did we skip the picture of the anatomical position somewhere? Yeah, all of those are anatomical positions. I guess we forgot to talk about. But we talked about it already, are we okay? Okay, so standing erect or lying prone. Palms are forward, arms are slightly down, face is looking that way, and why do we keep the arms like this?
We can tell the anterior and posterior part.
So well, but when you're standing here as a normal person, right, we never see anybody stand like this. We stand kind of our hands like this, or a lot of people will also stand with their hands like this. So these motions are pronation and supination, pronation and supination. One of the reasons we do this is when we do the pronation, the radius rolls in front of the ulna. And so that would cause confusion. And so what we do is we put the arm like this, so the radius is always on this side, hole is always on this side, they're parallel to each other, and we've got a nice position. Make sense?
Basically for ease.
Simplicity.
Yeah.
Yeah, simplicity. Yeah, so one of the things that, all those weird names in every science class that you took and how we did things, this is my personal opinion right now. You've heard that necessity is the mother of invention? It's not. Okay. Laziness is the mother of invention. The desire to go do something fun is the mother of invention. So what they did is they actually created these systems that you guys find aggravating at times, but if you use them over and over again, you know them, you realize it saves you a bunch of time. So if I write capital letter H on the board and I say, what is that? You would say, hydrogen. Okay, why did we do that? Because it's a pain in the butt to write hydrogen every time you want to do something. If you want to build structural formulas, writing out hydrogen, which is what they did originally, and putting in a line, was really hard. So hydrogen. If there's a pile of rocks here and you want them over there, what do you do? No, you get up and move them one at a time. There's no reason to have a wheelbarrow, except you are lazy. Or better yet, you just like to have fun. So we find ways to make the work less so we can have more fun. Does that make sense? So this makes everything simple. We don't argue about position. We don't make mistakes and cut the wrong part off and on position. All right. So what's I represent?
Proximal. Or proximal.
Proximal, J's, I on the leg. Still on legs too? Okay, J. All right. So all limbs are going to use that. What's G? What's H? What's D? Anterior or ventral, good. C is dorsal, good. E is F is inferior. Okay, cool. So you got all those. What type of anatomy is the most not? Example of gross anatomy. Cellular. Why?
Because you need a microscope.
Because you need a microscope. Oh, we got one right. That's worth $100. Okay. Oh, I guess I gave you that. A disturbance of homeostasis and disease that disturbance persists. So the pleura is blank to the pericardium and the blank to the diaphragm.
So it's C.
So what's the pleura to the pericardium?
Lateral.
Okay. And what is it to the diaphragm? So the answer is D. The answer is D. Okay. The surgeon makes an incision just inferior to the diaphragm, which body cavity will be open? Okay. Okay. So final round question. A receptor, a control center, and an effector are the three parts of a homeostatic regulatory mechanism. Which of these describes the respective functions of each component?
B.
We'll let everybody else get a chance to read it. I've got like 5 B's so far. Everybody made a decision even if you're not going to yell it out? The answer is B. Good job. So the sensor is going to be receptive to the stimulus. The integration center receives the information, decides what it wants to do with it, and then the effectors we're going to do something about the whole thing. Okay. Any questions?